In this short video, we're going to be talking about how to graph logarithmic functions. You will need your packet for Unit 4, and we will use the examples beginning on page 14 a little bit later in this presentation. So you may want to go ahead and get that out. Let's begin by talking about what a logarithmic function is. A logarithm is actually the inverse of the exponential function. You can see here in this graph, we have a graph of the exponential function y equals 2 to the x power. You can see here I have included the three basic points that are in every exponential function: 0, 1, 1, 2, since 2 is our base, and negative 1, 1/2. Here you can see that I have drawn the reflection line y equals x on our graph, so we can begin to do the reflection of this graph across that line, remembering that the inverse of a function is always the mirror image across this line y equals x. We can also get those points by just taking the coordinates for each point on our blue graph, which is y equals 2 to the x, and simply switching the x and y coordinates. So the point negative 1, 1/2 becomes 1/2 negative 1. The point 0, 1 becomes the point 1, 0. 1, 2 becomes 2, 1. And 2, 4 becomes 4, 2. When I connect my dots, I get the graph of the function y equals log base 2 of x. In this video, we're not going to spend any time talking about what all of these things mean. This subscript 2, which is our base, we'll get into that in later lessons. This lesson is just going to focus on how to graph the log function. A couple of things to point out. Just like our exponential function has a horizontal asymptote on the x-axis, when we reflect that and switch everything, then we get a vertical asymptote for the log function at the y-axis. So when this is in its standard position, it will not cross the y-axis. It'll get really close, but never cross it. Before we move on to do some transformations of the log function, let's talk about these 3 points right here. Just like when we learned to graph the exponential function, we focused on these 3 points to get our basic shape. We will focus on their inverses to get the basic shape of the log function. And all we've done is we have reversed our x and y's from our exponential function. So this point would be 1 over b, negative 1. This point would be 1, 0. And this point would be b, 1. And b can be any number, but in this case, b happens to be 2. Now let's look at some graphs, some transformations of the basic log function, and see how those graphs look. We're now on page 14 in our packet, and we're going to work these 8 problems together. The first problem is y equals log base 2 of x minus 3. Just like in all of the other graphs that we've done, we have an h and a k. If we look at this from a logarithm function standpoint, we would have the log base 2 of x minus h plus k. The plus k would be my up and down translation, and the minus h would be my horizontal translation. When I look at this function, I do not have a minus or a plus anything inside of parentheses. I just have a minus 3 right here. So that means that I'm going to take my basic log base 2 graph and it's going to drop 3 units. Here's what that graph would look like if I drop it 3 units. You can see that the point that used to be 1/2 -1 has now dropped 3 units to 1/2 -4. The point that used to be 1, 0 is now 1, -3. And the point that used to be 2, 1 is now 2, -2. If we begin to write what our transformations are and our domain and range, it would look something like this. Our translation would be down 3 units. Our domain, our x's, start at 0 but do not include 0 because the vertical axis is an asymptote. So it starts at 0, open on 0, goes all the way to infinity. And the range would be the set of all the y's, and our range is -infinity to positive infinity. Let's look at the second example. This one looks very similar. It's log base 2 of x plus 3, and that plus 3 is inside the parentheses. So this would be the same as our h. It's going to move our graph to the left 3 units. So let's go ahead and write that down for our transformation. Our transformation is left 3 units. So this is what the graph would look like if we move it to the left 3 units. Now note, I have redrawn an asymptote in here. The asymptote is not a required part of your graph. However, it is highly recommended you draw it so that you can have a guideline for what this portion of the graph will do. And since the y-axis was our asymptote, when we move it left 3 units, well then it becomes a vertical line at x equals -3. And you can see how each one of these points, our our 1/2 -1 moved over 3 units, our 1, 0 moved over 3 units, and our 2, 1 moved to the left 3 units. The domain, our domain has also been shifted. So the domain of this function is -3, open on -3, to infinity, and the range continues to be -infinity to infinity. Moving right along, example number 3. This example has 2 different transformations taking place. We have a -5 inside the parentheses and a +1 outside the parentheses. The -5 on the inside is a move to the right 5 units. The +1 outside the parentheses is an upward movement 1 unit. So we're going to take our basic graph, move it to the right, and up 1 unit. Again, I moved my vertical asymptote. This time I moved it to the right 5 units. So my new asymptote is x equals 5. And each one of my points, I moved right 5 units and up 1. So 1/2 -1 used to be right here. I moved it right 5 units and up 1. 1, 0 used to be right here. Move it right 5 units, up 1. 2, 1 used to be right here. Move it to the right 5 units, up 1. Draw my line to connect my dots. let's do the domain and range. The domain gets shifted to the right 5 units, so now it's 5 to infinity, and the range continues to be negative infinity to infinity. Let's keep rolling. Now we have y equals log base 2, x plus 2 minus 4, plus 2 in the parentheses, minus 4 outside the parentheses. That means that we are moving left 2 units, down 4 units. And that includes our asymptote. So here's what the graph would look like. Our asymptote's been moved to the left 2 units. And now all of our points, 1/2, 1, negative 1, gets moved to the left 2 units and down 1, 2, 3, 4. 1, 0, left 2, down 4, and 2, 1 moves to the left 2, down 4, and I connect my dots, and there's our graph. The domain is now negative 2 to infinity, and the range continues to be negative infinity to infinity. We are halfway done. We are on number 5 now. And see if you can guess what this one would be before we actually talk about it. We have log base 2 of x minus 4, and the minus 4 is outside of our parentheses. And that's going to mean that our only transformation is that we are going down 4 units. Because we're only going down 4 units, because there's no horizontal move, my asymptote doesn't change. I don't have to redraw it. And I just take my 3 basic points, and drop them 4 units. So this becomes 1/2, negative 5, 1, negative 4, 2, negative 3. The domain of this function is 0 to infinity, open on the 0, and the range hasn't changed, and most likely will not change. It's negative infinity to infinity. Before we do the next 3 problems, the last 3 problems, see if you can do those on your own. So hit pause, then come back and see how well you did. We're going to pick up the pace now for these last 3. We have log base 2 of x minus 4, and the minus 4 is inside parentheses. That means it's going to be a horizontal transformation, and in this case, it's going to go to the right 4 units. If we go to the right 4 units, it will change our asymptote, and it will change our domain. Here is the function after we've moved it to the right, the change in the asymptote, change in the points. And the domain is open on 4 to infinity, and the range negative infinity to infinity. Now we get to something a little bit different. Here in number 7 we have the opposite of log base 2 of x. And you've probably guessed that if we put a negative out front of our log function, that it will flip the log function horizontally, flip it about the horizontal axis. So our transformation is simply reflex across the x-axis. And here it is. It's been turned upside down. Our point that was at 1/2 -1 is now 1/2 +1. Our point that was at 2 +1 is now at 2 -1. Nothing happened to our asymptote. We just flipped it upside down. The domain and the range will not change at all when we just do a reflection across the x-axis. So we have open on 0 to infinity, and the range -infinity to infinity. Let's do our last problem. Before we do anything, we need to make a small editorial change. The problem is written as a -3, but I need you to change it to a +3. And the reason I need you to change it to a +3 is because, honestly, I made a mistake later on and didn't catch it till I got to this point in the presentation. So we're going to change this to +3. So with our newly edited problem, we have 3 transformations taking place in this function. We have a reflection because of the minus sign. We have a left movement, moving 3 units left because of the +3, and we are raising it 2 units. Let's write down our transformations. We have a reflection. We move left 3 units, and we move up 2 units. I'm going to do this in 2 steps because we've got so many things going on here. And I'm going to save this +2 for the end and just do the reflection and the moving to the left for the first step. Here's the first transformations. I have moved it to the left 3 units and then flipped it to reflect it. So now my point that was at 1/2 -1 got moved to the left 3 units and then flipped over the x-axis. The point that was at 1, 0 got moved to the left 3 units, and because it's on the axis, flipping it won't do anything. And the point that was at 2, 1 gets moved to the left 3 units and then flipped across the x-axis, so it becomes down here at -1, -1. Now let's do the last transformation where we pick it up 2 units. Alright, so the final piece, we're going to raise our graph, the pencil graph, up 2 units. So this point that is at -1, -1 lifts up 2 points to -1, +1. The point -2, 0 raises up to -2, +2. And this point, I wasn't being very accurate with my dots at -2.5, 1, which is where that should be. It's raised 2 units, and I was equally sloppy here. Would be -2.5, 3 units. Connect our dots, and there's our graph. That's graphing logarithms in a nutshell. Now there's a lot about logarithms we haven't talked about, like what does this even mean, this log thing? And what about this little 2 that we've got squeezed down here? All of that will come in due time. The purpose of this lesson, though, for right now, is to get in touch with the fact that this is how you graph a logarithm, and it comes from taking the inverse of the exponential function, which we saw way back at the beginning of this video. So now try your homework and be sure to bring your questions to class.